Hi friend, welcome to my channel. Today in this video you're going to learn elementary particles, and this is the first video of the series of elementary particles. This is the introduction part of elementary particles. So if you want to see all the upcoming videos, don't forget to subscribe my channel. So let's begin our today's tutorials. Here, elementary particles. This is the introduction of elementary particles. So let's begin. Elementary particles are those particles which doesn't have internal structures. Here I have already written that internal structureless particles are termed as elementary particles. There are so many parameters which is related to the elementary particles. Some of them are listed here. So first of all, first point is mass, first parameter. Mass, which is measured in energy unit. So if we have particles electrons, it will have mass 0.511 mega electron volts, and we know in particle physics all the mass is measured in mega electron volts. So one atomic mass of unit is equal to 931 mega electron volts. Okay, so if we have proton will have mass 938.3 mega electron volts. Neutron will have 939.6 mega electron volts, and so on. All the particles that I have listed here will have mass according to, here I have written all the mass of all the particles. Another parameter is charge. So elementary particles, they might have either positive or negative or zero charge. Another term is spin. So spin is one of the momentum which is use which is different for different particles. Like if you have bosons will have integral spin, or fermion will have half integral spins. So here electrons, proton, neutrons will have a spin half. Sigma cascade this is nothing. Okay, this is cascade. You can also write like this, will have spin half, and omega will have spin 3/2. Particle pions, kaons and eta will have spin 0, and gamma photon will have spin 1. So behaviors of particles and antiparticles are same. This is one point. Behaviors of particle and antiparticles are same. So if we have bosons, then we'll have spin 0, 1 to 2, 1 to 3, this integral multiples. And if you have fermion, then fermion spin will have half integrals, half 3/2, 5/2, and so on. So if s equal to 0, that will scalar or pseudo scalar, and if we will have s equal to 1, it will be vector or pseudo vector. Okay. Another thing is parity. Parity operation is such that it is the flip of coordinate system. Okay, so if we have r, and after operation we'll get minus r, that means parity changes. Here r is xi cap, yj cap and zk cap are the coordinates. So another terms is psi r comma t is the wave function of quantum system. So for parity for newtons equal to 1, and for anti-newton minus 1. Fermions opposite spin, since they are fermion opposite spin. Another terms is parameter is lifetime. So lifetime of elementary particles are, for newtons, lifetime is 10 raised to the 3 second. For pions positive and negative is 8 raised to the minus 8, 10 raised to the minus 8 second, and for pi naught it is 10 raised to the minus 16 second. For muon is 10 raised to the minus 6 second. So another terms is particles and antiparticles. What is the similarities and difference? So except a few particles have their antiparticles. Self-conjugate particles are those particles for which particle and antiparticles are same. Pions, eta, then quarks, W bosons, and neutrino. Particle and antiparticle have same mass, spin, and lifetime. They may have same parity if they are boson, and opposite parity if in case of fermions. Similarly, they have opposite magnetic moment and helicity. Here new terms helicity is arises. So what is helicity? Every matter particles, that is electron, quarks, etc., is spinning. That is, each matter particles carries some intrinsic angular momentum. So the helicity of a particle is defined as the projection of spin vector in the direction of its momentum vector. So sigma equal to twice s is spin and p is the linear momentum here. Okay, here magnetic moment of neutrons is minus 1.9, and for anti-neutron is positive 1.9, means the magnetic moment. So here is the main part of elementary particles. Whatever we learned here, it's just the introduction of elementary particles. So let's begin our main topics. This is classification of elementary particles. So on the basis of mass and on the basis of interaction, that is the elementary particles can be classified on the basis of mass and on the basis of interactions. So we know that on the basis of mass, if we classify on the basis of mass, that is particles which are having light masses, that is 0 to 134 mega electron volts, those are called leptons. Okay. Intermediate mass particles, that is greater than 134 mega electron volt but less than mass of proton, these are intermediate particles. And another is heavy mass particle, is greater than or equal to mass of protons. So let's talk about leptons. Electrons will have mass 0.511 mega electron volt, spin half, lifetime stable. For neutrino, that is 0 mass, half spin, and also stable. Muon mass will be 1056, 5.6, spin half, unstable, and anti-muon neutrino will have spin half and mass 0. Tau will have mass 1784, spin half and unstable, and tau neutrino will have mass 0 and spin half stable. Another thing is tau should be placed in heavy mass category because it has mass 1784, but it has most of properties similar to the other leptons. For example, it does not feel strong interactions, so a problem originated, and that will solve on the basis of interactions. So on the basis of interactions, a lepton, those particles which do not feel strong interactions, they feel electromagnetic and weak interactions. Hadrons, those particles which feel strong interaction as well as electromagnetic and weak interactions. These are hadrons. Here one thing is we have to notice that leptons will feel do not feel strong interaction. They feel only electromagnetic and weak interaction. That is, lepton will feel electromagnetic and weak interactions. Okay, and hadrons will feel strong as well as electromagnetic and weak interactions. So see, leptons, first generation, second generation, and third generation. First generation will have electron and electron neutrino, and they are antiparticle. That is, for electron it will positron, and for a neutrino we will get antineutrino. For second generations we'll get muons and muon neutrino, and they are antiparticles. And for third generation we'll get tau and tau neutrino, and then antiparticles. So if we calculate the total number of leptons, that is 4 into 3, that we will get 12 leptons with the leptons with their antiparticles, particles on with their antiparticles. Total will get 12. Let's talk about hadrons. Hadrons will classify into two categories. Number one is mesons and another is baryons. Mesons will further divide it into three categories, that is pions, kaons and eta mesons. And baryon will further divide it into two categories, that is nucleon and hyperons. These mesons will get, and these mesons are pseudoscalar mesons. Here pions will have triplet, kaons will have doublet, will get doublet, and eta will have singlet. Nucleon will have only two, one is proton and another is neutrons. And hyperons is further divided into four categories, that is eta, plus minus and 0, and cascade, lambda and omega. Sigma will have triplet state, and cascade will have doublet, and lambda will have singlet, and omega will get singlet. So thanks friend, this is the first video of elementary particles, series of elementary particles. In next video we'll learn another parameter related to elementary particles, and we'll solve some numerical related to elementary particles. Thanks friends, thanks for watching, and don't forget to subscribe the channels, and don't forget to share with your friends for more trusted video. Thanks friends.